International Symposium on Visualization in Transportation. I'm going to give a few remarks before we have the main event. Our two guest speakers come up and talk to us. But before I do that, I'm going to be introducing myself to a lot of you, hopefully all of you, throughout the next couple of days. And I only want to have to say this once. I broke my hand. I cannot shake hands with my right hand. I was playing hockey on Sunday, and I came in contact with a large metal pole that did not want to budge, and my hand is now broken, so I apologize if I don't shake, but I want to meet everyone and say hello to you, and thank you for coming here. This is a pretty exciting event. We have almost 80 presentations that are going to happen over the next 2 days, including a couple of workshops. We have one on color theory that's going to happen tomorrow morning. Teresa Marie Ryan right there in front. We have about 130 people who registered and are attending, and we had a record number of submissions this year, and it was hard to go through and decide who was going to be able to present with our limited space. Again, my name is Michael Pack. I'm the director of the CAT Laboratory at the University of Maryland. I'm chair of this year's symposium. This conference was put together every couple of years by the Visualization in Transportation Committee. It's part of TRB. Now, visualization tends to mean a lot of different things to a lot of different people. If we asked everyone here to define visualization, we'd probably get 130 different definitions of that. To some of you, it's about construction and pre-visualization or design. To others, it's about looking at data and performance measures or visualizing other sorts of data. To others, it's about how you communicate to folks. But no matter who you ask, it's about solving problems in some way, shape, or form that's plaguing the transportation industry. And hopefully over the next couple of days, these are all no matter who you are, visualization is some sort of way to solve a problem. And we're going to hear about 80 presentations over the next couple of days of people who are solving real-world problems in transportation. And it's particularly cool because it's really covering a diverse set of transportation problems. We have people here that are representing the transit industry, bike and ped folks. We've got several sessions on climate change and visualizing that. We have some TSMO, Transportation Systems Management Operations presentations. We also have a bunch of planning folks that are going to be giving presentations. We have the construction industry represented. We have unmanned aerial systems, drones represented at this conference. Virtual reality and augmented reality. There's even going to be some demonstrations of VR and AR technologies later this evening during the reception. Performance measures, safety, you name it, it's covered here during the presentation. And I also want to remind people that we have 2 different interactive poster sessions. So not your normal poster session where someone stands in front of a sheet of paper and explains, the research they did, but these are interactive in that we have 40-inch screens where people are going to be demoing their research and the tools and technology that they've developed. So please take time to go and visit and talk to those folks. And there is a reception this evening at 5:30, so stick around for some food and some networking. I would like to thank our sponsors, the CAT Laboratory, Atkins North America, WSP USA, the Bureau of Transportation Statistics, and the AAA Foundation for Traffic Safety. Without their financial contributions and their other contributions, this program would not happen and couldn't be the success that it's going to be. If you are not already a committee member or a friend of the Visualization and Transportation Committee, I would encourage you to do that. You can go to the TRB website and create your own profile. It takes just a couple of minutes, and you can find our committee. It's ABJ95. Visualization Transportation. You can become a friend, and you'll then receive all the emails about committee activities, and it can help us define research needs and be an active part of the committee. Last but not least, I'd also like to thank our planning committee, which included Frank Broen from Teach America, Kevin Gilson from WSP, Patricia Hu from the Bureau of Transportation Statistics, Charles Latimer from Atkins, and Jason Williams from True Simulation. And plus, there were many other people who helped us review the record number of abstract submissions that we had this year. So thank you to all of those folks. And I would also like to thank the TRB staff who worked behind the scenes to make this, this program a success. And that includes Scott Babcock, Kate Debelak, I don't know if I'm pronouncing that right, Kiara Dorn, Rhonda Levinowski, and Patty Lockhart. So thank you very much to all of those individuals. And with that, we're now to the exciting part. I'm going to welcome Patricia Hu from the Bureau of Transportation Statistics up to the podium to introduce our next keynote speaker.
Good morning. This is my greatest pleasure to welcome our Deputy Assistant Secretary for Research and Technology, Ms. Diana Furchtgott-Roth, to this 9th International Visualization Symposium. So let me just give you a little introduction to Diana, but her complete bio is in your program. So since she joined the department early part of this year, her focus has been on the implementation of innovation in American transportation system, and at the same time lowering the bar for any new technology development. So before she joined the US DOT, she was the acting assistant secretary for economics policy at the Department of Treasury, a senior fellow and the director at the Manhattan Institute for Economics Policy, and a chief economist at the Department of Labor. So she received her BA from Swarthmore College and her master in philosophy in economics from Oxford University. So please join me to welcome our Deputy Assistant Secretary, Diana Furchtgott-Roth.
Well, thank you so much, Michael, for organizing all this. And thanks so much, Pat, for inviting me to speak. It's really great to be here. And I just want to tell you how important visualization is and how Secretary Elaine L. Chao always wants to have maps and graphs. And I want to start out by telling you a story about how we had been trying to get better computers for visualization at BTS, at the Bureau of Transportation Statistics. And there was Hurricane Dorian, and the secretary wanted maps showing the passage of Hurricane Dorian and how it was affecting different transportation infrastructure. Well, these computers had been on order for months and months, and it gave me an excuse to call up and say, we need these computers right away. Well, they didn't give us the computers right away because being a government bureaucracy, it's very difficult to get things right away, but they brought us temporary computers, temporary faster computers so we could do faster maps. So this is extremely, extremely important to us. Well, I don't know how much you know about the Office of Research and Technology at the department, but I oversee the research in the different modes. That's the Railroad Administration, Highways Administration, FAA. We have 7 modes that do different kinds of research. We have $1 billion worth of research in the modes, and we use visualization for this to show how the different modes are doing research in different categories. I oversee the University of Transportation Centers. That's about $75 million in research. We have the Intelligent Transportation System Joint Program Office that does cross-modal research. We have Volpe, which is our research center in Cambridge, Massachusetts. That's about 1,000 people, and that generates research not only from the department, but also from outside entities such as Millennium Challenge or the UK Department of Defense. It's very, very highly regarded. As you know, we have the Bureau of Transportation Statistics, and we have our Transportation Safety Institute in Oklahoma, which provides classes in different aspects of emergency management, transit, if there's fires on rails, goes around the country with different professors setting up different courses. And I also manage our position, navigation, and spectrum office. We are working on a backup for GPS. And as you can imagine, visualization is extremely important for that, to show how GPS travels or how it can be used in different areas. And also, I look at preserving our spectrum, the 5.9 band of spectrum for connected vehicles. Well, the theme of this symposium over the next 2 days is a better view. And this is a very, very fitting theme. Secretary Child's #1 priority is safety, and sometimes all it takes to change lives is a change in perspective. I'd like to start with a small story. In 1854, cholera broke out in a neighborhood near the center of London. Hundreds of lives were lost, and no one could find a cure. This changed when John Snow had the idea of taking a map of the neighborhood and plotting a scattershot of homes of people who had died. He noticed that many of the deceased individuals lived near and drank from the Broad Street water pump. Removing the handle of the pump ended the neighborhood epidemic, and all it took was a better view of the problem. And that saved probably thousands and thousands of lives in London from cholera. Well, today our visualization tools are much more advanced than those of Dr. John Snow, and the potential benefits are correspondingly greater. So I'd like to share with you some of the examples of the visualization work that we do and we sponsor in research and technology. Now, my staff, unlike all of you, is not sophisticated enough to put up these graphs for you in this PowerPoint here. We do them at the transportation department, but I haven't managed to bring them here. So I want you to imagine how much better this talk would be if I had a PowerPoint showing all these different things that we do. Well, data representation, data visualization, is a graphic representation of information and data. At its best, data visualization uses charts and graphs and maps, and every day trillions of new data points are created. One of the most immediate applications of data visualization is used for managing the research spending that we have. Increasingly, we're using visual tools to monitor the priorities. We're beginning to explore artificial intelligence tools that will let us visualize topics and content throughout the entire portfolio of current and past BTS research. For example, we know the Secretary's priorities are safety, infrastructure, accountability. So what we have done is we've asked all the modes to categorize their research into those different categories. And then what we do is we can provide pie charts of how the research is actually mapping against the Secretary's priorities. So for example, we noticed that safety was the #1 priority, but sometimes it does not show up as the greatest source of research expenditures. So that's something that enables us to fix that particular problem. Well, there are many, many BTS applications. BTS maintains hundreds of data sets that serve as invaluable assets to leadership when creating policy. And Pat Hu and her staff have developed many, many visualization tools. For example, we have the local area transportation characteristics by household database, and that provides data on vehicle trips and vehicle miles. And this tool allows patterns of data to be easily analyzed and interpreted, while also allowing users to zoom in to an individual neighborhood that they might be interested in. For city leaders who are planning changes in their transit systems or trying to contextualize the effect of new technology, such as ride sharing, this tool provides detailed demographic data and information that cities would be able to look at and they would be unable to collect on their own. For example, what we can do is we can show for e-scooters, we can show the location of where e-scooters are over the country and show how it has grown over the past 5 years or so, or ride sharing, using tools to do that. BTS also has a catalog of fixed guideway and fixed route transit services that allow researchers and the American public to visualize transit data across the nation. And this provides detailed spatial data as well as information about frequency and timing. BTS maintains other visual tools, and here we're going to have a booth right here at the conference, and you can go and you can have a look and see everything that they're doing. At the University Transportation Centers, we've recently funded more than 40 projects related to visualization, with many of these focusing on improving safety. At San Diego State and Virginia Tech, researchers are working to model aggressive driving and use big data visualization tools to identify aggressive driving behavior. They will conduct simulations to identify high-risk zones where aggressive driving frequently occurs. These simulations will likely improve as connected vehicle technology becomes more and more prevalent. Researchers at the Missouri Institute of Science and Technology in St. Louis and also in Rowan University, New Jersey, are developing models to assess the extent of flooding in these different areas due to extreme weather events such as Hurricane Sandy. They're able to evaluate the efficiency of existing infrastructure. Some plan to develop a mobile data-friendly visualization Android application to provide flood data and information for communities. So you can map if the rain falls or when the rain falls. Depending on the number of inches, you can see how much it's going to be flooded. When I was at the Missouri University of Science and Technology, I put on these virtual reality headsets and goggles that showed how you can, it appears as though you're flying over an area and you can see the flooding that would occur in the event of a rain. It's very, very realistic. When you're flying over, you even get airsick with this virtual reality. The ITS JPO, Intelligent Transportation Systems Joint Program Office, is doing excellent work both collecting and visualizing data. It's a one-stop shop for ITS-related primary and derived research data from the department. One example of visualization is from Pasadena. This data set contains road link level simulated data for several months. The Data Hub visualization page displays a simulated 24-hour period in one of the busiest parts of Pasadena. Another example comes from a data set produced by vehicles that are equipped to record basic safety messages. The systems collect vast amounts of data across a wide number of variables, and interpreting these data are challenging. We have a data hub that creates an interactive visual that conveys the breadth of data collected by such systems. Well, safety is the department's #1 priority, and there are many, many applications that we can use to keep Americans safer. I just want to conclude by saying that we are very, very much looking forward to hearing about all the applications that you are doing. We're looking forward to hearing suggestions from what we could be doing better in the visualization challenge, and looking for suggestions that if I come back next year, you can tell me what I can put on the screen to make my talk even more effective. Thank you very much, and I would be happy to take questions if there are any questions.